they are given some solve dx by dt equal to 3x minus 4y and dy by dt equal to x minus y here. By the same method, you can solve this problem. So first of all, you have to finding the roots, whether the roots are real and distinct or real and equal type, which type the roots are. So according to that, you can find out the general solution here. So here, so for 2 by 2 matrix, the general formula is A1 minus M into capital A plus B B1, A to A plus B2 minus M into B equal to 0. So this is the general formula for the 2 by 2 matrix ma. So you can either use this formula or it is or you can use by this method also. So here you are taking x value and y value is a into e to the power mt and b into e to the power mt. You have to differentiating that term means a into e to the power mt into m. Dy by dt means the differentiation term is b into e to the power mt into m here. So you have to substitute that term. So dx by dt value equal to x plus y here. That problem 3x minus 4y here. So you have to substituting that term 3 into x value. That is a into e to the power mt and 4 into y value b into e to the power mt here. Similarly, x minus y means a into e to the power mt minus b into e to the power mt here. So you are substituting that dx by dt value. That is a into m into e to the power mt on the left hand side of the equation, and similarly dy by dt b into e to the power mt into m, and on the right hand side of the equation you have 3 into e to the power 3a into e to the power mt into minus 4 into b e to the power mt here. Similarly on the right hand side you got here also. So you can derive by that step also, or else if it is difficult for you means you can easily replace this formula. You can taking that a1 b1 a2 b2 from the above equation. That is a1 is nothing but 3 here ma, and b1 is nothing but minus 4 here, and similarly a2 is nothing but in the second equation coefficient x coefficient is 1 here, and b2 is nothing but minus 1 here. So you directly you can substituting this formula also. So that is 3 minus m into a minus 4 times b here, and 1 into a plus minus 1. You have to substituting the b2 value, that is y to coefficient is minus 1 here. So minus 1 minus m into b equal to 0. So keep it as equation number 2. So it can be derived in two ways. Directly substituting the x and y value, you can simplify and equating means you got that value, or else directly you can substitute this a1 a2 b1 b2 value in this above formula. You got that term. So now you are taking the coefficient of a and b here. So coefficient of a is 3 minus m here, and another coefficient is 1 here. Similarly, coefficient of b is minus 4 and minus 1 minus m here. You are taking the determinant here, that is 3 minus m into minus 1 minus m here, and minus of minus 4 is plus 4. You can be taken on you have to multiply that individually. You got 3 into minus 1 is minus 3 here, minus m into minus 1 is plus m here, minus m into minus m is plus m square here, and 3 into minus m is minus 3m here, plus 4. So you have to taking m square, minus 3 plus m is minus 2m here, and 4 minus 3 is 1 here. So m square minus 2m plus 1 equal to 0 means this is of the form m minus 1 the whole square equal to 0. So its expansion is m square plus 1 square minus 2 times m. So m minus 1 into m minus 1 equal to 0 means m equal to 1 into 1. So the roots are real and equal. In previous problem, the roots are real and distinct. So you can use the first formula. If it is real and equal means you can use the third formula, that is x equal to c1 into a into e to the power mt plus c2 into a1 plus a2t into e to the power mt. Similarly, y equal to c1 b e power mt plus c2 into b1 plus b2t into e to the power mt here. So this is a formula you have to substitute it here. So first thing, you have to substitute m equal to 1 in equation number 2. You got equation number 2 is what? 3 minus 1 in minus 4b equal to 0. That is 2a minus 4b equal to 0. In second equation, you have to substituting a plus minus 1. That is minus 2b equal to 0. That is a equal to 2b. So here you have to substituting b value equal to 1, that a value equal to 2 here. Here 2a equal to 4b means a equal to 2b. This is also here you have to substituting b value equal to 1, a value equal to 2. So because it is real and equal, so both the a value and b value are same here. So a equal to 2 and b equal to 1 here. That is a into e to the power mt formula. So a is here 2. So 2 into e to the power m is nothing but 1 here. So 2 into e to the power t. Similarly for y, it is b into e to the power mt here. So b is what? 1 here. So 1 into e to the power, that m value is 1 here. So 1 into e to the power t here. So now you are taking the roots are real and equal means you got x equal to a1 plus a2 into t of e to the power t. So if it is a complementary type, in previous unit you have to derive, if it is real and equal means ax plus b into e to the power mt, or else a plus bx into e to the power mx. Likewise, we can derive in unit 2. Here we have to find out that both x and y here with respect to t. So here you are using that a1 plus a2 into t into e to the power t here, and b1 plus b to t into e to the power t. So these are the complementary function. Now you are differentiating this term for identifying dx by dt and dy by dt. So for that, you have to differentiate this above term. So differentiating dx with respect to t means you got, first of all, you can take the uv derivative, uv dash plus vu dash formula. So you are taking that e power t, and you have to differentiate that a1 plus a2 into t. So a1 is constant here, so 0 plus a2 with respect to t means you have to taking a2 into 1 here. Similarly, you consider the term a1 plus a2 into t as it is. You have to differentiating e power t, you got e power t here. So now you are taking all the e power t as common So the remaining term is a1 plus a2 plus a2 into t here. Similarly, by the same way, you have to differentiate the y term here. So y with respect to t, dy by dt equal to, you have taking e power t as common, you have to differentiate b1 plus b2 t. So b1 is constant here, so 0 plus b2 into 1 here. Similarly, you can taking the b1 plus b2 t as it is. So you have to differentiate e power t. So you got e power t here. Similarly, you can take the e power t as common here. You got b1 plus b2 plus b2 t here. So you substituting this value in the first given equation that is dx by dt equal to, instead of dx by dt, you have to substituting this term, and instead of x and y, you have to substituting this terms this a1 plus a2 into t e power t. So here you have to substituting all those things. Equation 1 changes That is dx by dt value is nothing but a1 plus a2 plus a2 into t of e to the power t on the left hand side. Similarly, dy by dt value is b1 plus b2 plus b2t into e power t. It is on the left side value. The right hand side is 3x minus 4y. And the second equation is x minus y. So for that, 3 times x value is a1 plus a2t into e power t minus 4 times y value is b1 plus b2t into e to the power t. Similarly, x value is a1 plus a2 t into e to the power t minus y value is b1 plus b2t into e to the power t. So now you are taking all the term in one side ma for solving this type. So first of all, you have to entirely divide the term by et here. So et cancel on both that equation itself. So both the RHS and LHS, all the et terms are, e power t terms are cancelled here. So the remaining term is a1 plus a2 plus a2t equal to 3 times. You have to multiply it individually. 3 times a1, 3 times a2t minus 4 times b1 minus 4 times b2t here. Similarly, in the second equation, b1 plus b2 plus b2t equal to a1 plus a2t minus b1 minus b2t here. So you are taking all the term to the right hand side ma. So 3a1 minus a1, that is 2a1 here. Similarly, 3a2 minus a2 is 2a2 here, 2a2t here, and minus a2. So minus 4b1 minus 4b2t, which is equal to 0. So all the left hand side of the term goes to the RHS side. It becomes minus. Similarly, a1t plus a2t minus b1, and again another minus b1 is that. So minus b1 is minus 2b1. Similarly, minus b2t minus b2t is minus 2 times b2t here, and plus b2 go to the right hand side means you got minus b2 here. So that term equal to 0. Now you are taking all the constant term one side and plus the coefficient of t in another side. That is 2 times a1 minus a2 minus 4b1. These are the constant term in the first equation, and plus t times, you have to taking the t term as common. The remaining equation is 2 times a2 minus 4 times b2, which is equal to 0 in the first equation. Similarly, in the second equation, you are taking constant term as a1 minus 2 times b1 minus b2 here. Similarly, you are taking that t coefficient as a2 minus 2 times b2 here. Now, you are equating the term equal to 0 ma. Either the constant term equal to 0 or the coefficient of t equal to 0. Since t not equal to 0, you are equating the coefficient of that term equal to 0. So 2a1 minus a2 minus 4b1 equal to 0, and a1 minus 2b1 minus b2 equal to 0. This is a constant term that equal to 0, and again coefficient of t term equal to 0. That is 2 times a2 minus 4b2 equal to 0. a2 minus 2b2 equal to 0. So here you are solving this. 2a2 equal to 4b2 is a2 equal to 2b2 here. In the second equation also a2 equal to 2b2. So you are solving b2 value equal to 1 means a2 value equal to 2 here. In both the equation, b2 value equal to 1 means a2 value equal to 2. So now you are substituting this a2 value and b2 value in equation number 3 ma. So the equation number 3 changes into 2a1. a2 value is what? Minus 2 minus 4b1 equal to 0. Similarly, a1 minus 2b1, b2 value is what? Minus 1 equal to 0. So now you are taking the constant term to the right hand side. So the minus term becomes plus here. So minus 2 goes to the right hand side, it becomes plus, and minus 1 goes to the right hand side, it becomes plus 1 here. So 2a1 minus 4b1 equal to 2, and a1 minus 2b1 equal to 1 here. Now you are solving this ma. So You are substituting B1 equal to 0 here. So A1 value equal to what? 1. Similarly, in 2A1 minus that 4B1 value equal to 0, 2A1 equal to 2 means A1 equal to simply 1. So in both the equation, you substituting B1 value equal to 0 means you got A1 value equal to 1 here. So, in previous problem, you have to derive the solution simultaneously. But in this problem, first of all, you have to identifying that A2 and B2. Again, you have to substituting that A2 and B2. You have got A1 and B1 here. So, A1 and B1 value is here 1 and 0 here, and A2 B2 value is 2 and 1 here. So normally complementary function formula AX plus that is A1 plus A2 into T into e to the power T. So you have to substitute all the A1 A2 value here ma in X value. So A1 is what? 1 plus A2 is what? 2 here. So you have to substituting 2 times T into e to the power T. Similarly, B1 is what? 0 plus B2 is what? 1 here. So 1 into T into e to the power T. 0 plus T into e to the power T is simply T into e to the power T. First equation is 1 plus 2T into e to the power T. So this is what the required complementary function ma. But finally you can write it as C1 into that term and C2 into that. So you have to writing the general solution by using X equal to that is. So normal form for the real and equal type formula is what? Wait, I will show you. C1 into A into e to the power mt plus C2 into A1 plus A2t into e to the power mt. So already you derive the second solution. That is C2 solution. Already you can derive. You have to write C1 here. That is C1 into, wait, I will show you. This solution, you write it, this solution here. C1 into 2 times e to the power t. Similarly, plus C2 into, here you derived 1 plus 2t into e to the power t. By the same way, you write it for y also. Already you derived one solution for y, that is e to the power t. That is C1 into e to the power t in the first one plus C2 into the second solution is what? T into e to the power t. So you can all the values separately. Finally, you can adding that term C1 and C2 here. So this is what the general solution. Okay. For real and distinct means there is no problem. You can derive the solution simultaneously and substituted it simultaneously here. But for the real and equal type, you can derive first one solution is there. And again, you can derive another solution. That solution can be added with the first solution. This is what how the general solution is derived here. Okay. So this